Hi everyone. Hello Boston. Really happy to be here. Thanks for having me. Today I didn't bring any electronics and drones and stuff like that, but we will talk about really cool things that you can do with AR. I will talk about building AR apps in React Native. So a bit about myself. My name is Vladimir Novick. This is my fancy logo. I'm an independent consultant. I consult various companies in web, mobile, VR, AR, and IoT fields. Probably I should add AI and blockchain to be on top of like every buzzword out there, right? But yeah, not for now. So this is my Twitter handle on the which side? On the left side, and my website if you want to follow and just to say hi. So I want to talk about augmented reality. So what is augmented reality basically? Lots of people think, well, it's a digital overlay over our camera of some sorts, and it can give us, it can basically augment our real world with some kind of digital overlay. But it's not only that. For example, all our senses that can be changed in a digital way, let's say sounds, or like you have a running app with audio book playing, stories of some sorts, it's also augmented reality. So today we will talk about the visual part of it. But I want you to understand that augmented reality is not necessarily only the visual part. It can be like our other senses, it can be haptics, it can be anything that augment our real world. So the question is why AR is the future, and basically it's reality 2.0 version, which means we live in real great world, but we constantly using our phones, we constantly use our computers, and we constantly live in both worlds. We already are augmented humans, basically. We already half of our time we are on our phones. So how cool can be if we can augment the real world with a digital overlay? So we won't need to stare at the screens. So for example, at some point we'll have glasses, we can walk around and see ads. Well, yeah, that probably will be the first implementation because like business, right? But yeah, at some point it will be, I hope it will give us additional context, additional good things. For example, there is a augmented reality ski goggles that you can put, and you can get some kind of like gaming experience where when you ski down the slopes, like you pick up coins of sorts. So there is actual thing there. You can Google it. That there is one. But I want to talk how it all started. So when do you think was the first mention of AR? Just yell out the year. 62. Well, 1901. Yeah, that was the 62 is pretty much close to the actual AR. But 1901, there was a book called The Master Key. In this book, the main character, he got some kind of medallion that showed type of character above human people he met. So if it was a good person, he would have seen G, and like if it's an evil, then E. So it was the first mention of AR. In 1952, there was Sensorama, which was a huge machine. You just stick your head inside the monitor. It literally looked like that, and it gave you some kind of AR experience. In 1968, there was really cool stuff called Sword of Damocles, and it was actually the head-mounted display. It was called like that, based on Greek mythos. I didn't remember the whole story, but the idea was the sword, or destiny sword, that was hanging somewhere above you, and if it falls, you obviously die. The same thing was with this headset. It weighed 2 tons. It hung above you, so if it would fall, then you would, yeah, you would die. So, so in 1982, there was AR for weather broadcasters. In 1992, there was virtual fixtures. It was I will show you a picture in a bit. it was sort of combination between VR and AR, and actually because rendering engines was not there yet, it used robots and cameras. We'll see it in a bit. In '96, there were first AR markers. So the markers in AR, the concept of markers is basically an image that you can scan with something, and you can overlay a 3D model on this marker. Then we had dashboard for X38. Right now on lots of airplanes we have AR. 1999 it was iTap, which was the first prototype of Google Glass-ish thing. And in 2008 AR got into commercial use by BMW, then Kinect, Google Glass. First markers and manufacturing, and then we got to the really cool point 2 years ago when investment in AR and VR reached 1.1 billion. So businesses recognize the potential of AR and VR and recognize how that they need to invest into this. In 2016, there was Microsoft HoloLens and Meta 2 headset. Who have heard about the HoloLens headset or Meta? Nice. So the idea is just a computer you put on your head. It gives you augmented reality. We'll see it in a bit how it looks. Actually, it looks like, not in the ads. 2016, probably you have heard about, or maybe you have played Pokemon Go the same year. And last year we had ARKit and ARCore introduced by Apple and by Google. And this year we have Magic Leap, which is a really cool thing. I haven't tried that, so I cannot judge it from my point of view, but the idea was light field technology, basically occluding 3D objects with real objects. It's a really cool thing. You should definitely check this out. So this was the Sensorama. So I was not kidding about putting your head inside the monitor. So that's what the thing. This was the sword of Damocles. So you imagine if this thing falls, then you die. Virtual Fixtures looks like Robocop. But because it was like robots combining with cameras and was sort of that thing. Cybercode, this is the markers. This was the iTap. So Google Glass basically did really cool design and styling thing, but this actually worked on the iTap. This is the HoloLens, and this is the Meta 2. And that's what we see in the ads of HoloLens, and it looks pretty neat, but that's the actual field of view. So we are not there yet in terms of like AR glasses, but for some specific purposes, like in this example, for example, doctors use HoloLens to get the radiation dose on the, I don't know what the thing. So here we don't need huge field of view. We need just a tiny portion of view. And this is the Magic Leap. So they told us it will be a fancy headset. It doesn't look fancy to me. But that's what you see on their ads, and it looks pretty amazing. I don't know how it looks like in real life. So if you tried, tell me how it looks like. So yeah, at some point, yeah, right now, we probably haven't listened to our moms and we have TVs strapped on our face. And sometimes AR can get into weird parts, like finding Pokemons in weird places. So yeah, jokes aside, how we can use AR today. So I have several options. We can use AR for retail, for example. We can preview products before buying. So for example, if I'm not mistaken, in Wayfair app, we can preview the product, right, in AR. We can get deals based on physical markers. I told you about the markers in AR, so we can put some kind of markers in the store and get some deals or stuff like that. Can get additional info about products, share product images with friends, before purchasing. And it looks like this. So you probably tried some kind of app like that. If you haven't tried, you can just search on AR category on either of stores. It will have a bunch of those. And it looks like this. Again, bunch of ads. Yeah. So we can use AR for games. We can interact with the digital world by leveraging physical environments. Sometimes it can be pretty disturbing. The case with Pokemon Go, like there were like lots of injuries because of interacting with physical world and digital without like looking or stuff like that. It's much more addictive. So, for example, for VR, you need to put headset on. You're totally separated from environment. You're totally inside this thing, and when you're in the real world, it's sort of more addictive. Social sharing is easier. You can explore physical world with digital overlay, and it looks like this. For example, this is a card game. How cool is getting some kind of magic effects on this magic card game? Or like getting a bunch of Street Fighter models doing their thing. Or you've probably seen lots of stores marketing on these AR toys, which is basically taking the phone, putting it on your gun, and just like pretending you're shooting things. AR is used for manufacturing. You can get valuable information without distraction, instructional videos, set of tools. And it's actually pretty useful. Instead of reading manuals, instead of actually learning, people use AR, and yeah, sometimes things fail. We can use it for location-based AR for getting various informations based on geolocation, based on various markers. And basically, it looks something like this. So it will help us to navigate the world and see. Instead of looking at the map, you just point the camera. I know it looks weird from the side if like someone looks at you like pointing a camera and just walking around looking at stuff. But I mean, when Bluetooth headphones went out, like everyone looked pretty weird, just talking to themselves, walking on the streets. And right now it's fairly common. So at some point it will also be common. So how we can get started, like literally, speaking about the code and speaking about the libraries. So we can use, there are several libraries we can use. We can use React Native ARKit or React Native ARCore, which are basically wrappers for the native implementation of ARKit and native implementation of ARCore. But there is a problem with that. They're not maintained for half a year. Which is not good. Well, that's why we wouldn't use it today. We can use Unity 3D or Unreal, but this is more for like creating actual complex games. And we can use Vero React. So Vero React, basically, Vero Media Platform, is a free of use platform that you can. It has Vero React part, it has Vero Core part. So if you write in Java, you can, Android Java, you can just write in Vero Core. But Vero React targets both environments. It's written on top of React Native and has various benefits. It has real-world 3D tracking, surface detection, markers, all kinds of effects, like particle effects and stuff like that. And most important, it runs on the native side. So the whole render is not in JavaScript, it's on the native thread. So it's really powerful. So in order to get started, you get your API key from veromedia.com. It's just you put your email, you get your API key by email. You can get like tons of these API keys. There's no limitation to that. You install globally React Vero CLI, and then you just init your awesome app. So let's see this awesome app and how it actually looks like, and I really hope this will work. I have a backup plan, so we'll see. That's screen mirroring. Yeah, why it should work? It wouldn't work. I'll try it again. Okay, cool. So, where is it? Let's make it bigger so you can actually see what's going on. So I have this AR monster up. I basically have to experience either VR or AR, but I will check AR. So, so it's a little bit chilly. So it started to snow, but it's not the only problem here. That's me trying to scan things. It looks weird, but yeah. So this guy is standing over there, right? And it looks real. It has shadow. So the shadow is on the. Yeah, I thought I will trip over something. That's why it's dangerous, right? So in addition to that, let's make it more dangerous. If I will be able to scan things again. Yeah, so I have this window over here. So it's called portal. So if I look into this portal, I can actually walk into this portal. And the cool thing, if I turn around, over there, right? But I should get out because it can close. And then I will be left in the digital world. Yeah. So let's see how we actually create those kind of things. This is the repo, so if you want to check the code later, you can do, but we'll walk through the code. So we'll talk about the basic anatomy of an app, Vero app. So we have app.js, which has a render method, like regular render. And the important thing is here, get AR navigator. This is basically checking if I pick AR or VR experience. So my AR navigator uses VRC navigator, and we can have several AR scenes. So currently I have only one. This is my initial AR scene, which is like AR monster. By the way, there is a hashtag AR monster. So if you tweet about the monster, tweet with the hashtag, because it has a history of conferences. It appears at various conferences because like I like to bug people with AR stuff. This is the basic structure of our AR monster file. We have the Vero AR scene that actually wraps every AR scene. It has various methods. One of which, one of these methods, for example, is on track updated, so we can know when we are tracking or when we are not tracking. So if there's a problem with ARKit tracking or ARCore tracking, we will get notification. We will do anything we want in this app. Then we have various light. Well, actually, we have only one. Have directional light. We have text. We have plane selector. So we set up all lights. We position UI, and we have this helper to select AR surfaces. So you've seen this like semi-transparent gray quad that was on the ground when I tried to put the monster on. So this was the Vero AR plane selector, and we'll talk about this in a bit. So yeah, we have positioning here. We have position and rotation. So let's talk about positioning. So Vero used right-handed coordinate system, meaning if I take my hand, point at myself, this while the middle finger is z-axis, y, and x. Meaning if I want to position anything in front of the camera, I put it on negative z. This is important because, for example, if you use Unity, it uses left-hand coordinates. So this is the one thing. So positive z is behind the viewer. Axis direction changed when applied rotation prop. So for example, if we have various nested objects and I applied position and rotation on that object, my axes are changed. And I can determine this by the thumb rule. So if I point my finger along with the axis and, for example, I want to give a positive rotation of 90 degrees, so the positive rotation will be along my fingers. So I can determine where the rotation goes, and then I can thing how axes are transformed. So for example, here, yeah, and we have Flexbox for UI, which is cool. For example, rotation here, -90, it transforms all the axes for the nested children. So everything here will be rotated on x-axis. So let's talk about lights and materials demo. So I thought about just putting a bunch of pictures how lights work, but it's probably better I will show you inside Unity how they work, and then we will transfer this to Vero, how it works with Vero. So I have this scene, for example, just like post-apocalyptic theme. I have this cube. So there is directional light. Directional light is like a sun. So it's like a sun. And if I change the direction of the sun, it basically reacts according to, like, for example, it's night right now, right? So there is a point light. If I, for example, here enable point light is just points in space that generate lights in every direction. There is a spotlight, which is actually point light is an omni light in Vero syntax. And then there is a spotlight, which is a cone that you can change. So in Unity, you have all this editor. That's why Unity is cool for like creating all these cool game experience and stuff like that. But for not necessarily for simple things. I've created games with Vero too, and it's possible. It's just if you have like lots of effects and stuff like that, it's probably better to go to Unity to create those. So yeah, materials. And speaking of materials, we have several concepts. So let me just turn my light, turn my sun on. Yeah, so this cube is basically just plain cube. And if I go to my material, I have some properties, and we'll see in a bit how it looks in Vero. So I have albedo. In Vero, it translates to diffuse map. So my diffuse map will be, let's say, this one. So it means giving a color texture to the object. Then we have a normal map. I'll try to zoom in so you will see the difference. If I add a normal map to any object, it gives it details. So you see subtle details that are added to objects, to this object. So it's not a mesh, it's just a shader. The same you can do with Vero. So that's in a nutshell how lights and materials looks like. And speaking about lights, let's look how let's check how they look in the context of Vero. So we have ambient light, basically a light that illuminates everything, not just as a sun, it just illuminates everything. It's good for giving one color for all of your objects in the scene. For example, you want some kind of tint to all of your objects on the scene. You have the directional light, which is have various properties specifically for shadows. Have, for example, cast shadow true. It basically means every Vero quad, it's like rectangle, every quad that gets AR shadow property will cast on its shadow produced by directional light or by spotlight. So spotlight will get inner angle and outer angle, directions, positions, colors, and stuff like that. So you see the prop of cast shadow. It appears here, but there is no cast shadow on ambient light because it's ambient light. It just surrounds your object. So it's like sun. Directional light is like sun-like light and spotlight. Materials we can create pretty much similar as you create the style sheet.create. So here you do Vero materials.create, and you specify, for example, ground with culling mode, shyness, diffuse color. This is the actual color of the material, and lighting model. So there are several lighting models that are specified in Vero docs. Lighting model is basically a mathematical function that explains how to lead the object. If it's reflected, if it's has like softness of sorts and stuff like that. And in order to apply our materials, we use materials prop and just pass a string to array of materials. So we can merge several materials together, which is cool. With textures, we have diffuse texture. You've seen this as albedo in Unity. Here it's diffuse texture. We have specular texture, which is basically how object is shiny. We have normal texture. And this is how the monster actually looks. So this is the diffuse texture. This is a normal texture. So all the bumps on the monster was produced by this normal map, and this one was the coloring of the thing. So 3D models can be imported like 3 types of file. We can use OBJ file, we can use VRX files, and we can use JLTF. So the question is, well, probably if you've dealt with OpenGL and in general with 3D modeling, development, whatever, so you heard about FBX, but you haven't heard about VRX. So VRX is Vero-specific extension, and it has a transform script that you can run on your FBX model and basically transform it to binary with extension VRX, and you can load it inside the engine. And JLTF is a combination of JSON, binary, and various textures. This is sort of a new format, and so it's also supported. And this actually is the model that you will get if you don't load any textures. So sometimes you can download a model, load it inside your app, everything seems pretty cool, but you don't see any textures. So let's see how we can actually load model with the texture. So this is the actual code of the demo. And I have the Vero node. Vero node is like a view, basically. It's like a node in the space that you can you can put position and rotation on it, and basically an empty node, and you can nest your nodes inside of each other. So 3D object and any object, basically, it extends Vero node. So there is 3D object for loading models. So here we load monster VRX, and we load resources. So if I have various resources, in this case I have 2, diffuse and normal map, I can load it here. And I have a bunch of callbacks like onload end, and for example, you've seen monster was like staying in the like idle state, he was moving. So the cool thing, you can load models with skeleton animations, and Vero supports skeleton animations. Meaning you have a model from 3D program, you get FBX file, you have set of animations on this model, you load it inside the engine, specify which animations you want to try to run, and it will run them. So it's pretty cool. And this Vero quad is the shadow. So AR shadow receiver is the shadow. So you load the resources, yeah. So let's talk about magic, the detection of AR planes. So all these gray quads you've seen on the floor and actual detection, how it worked. There is Vero AR plane component. It's a low-level component. When you get various, you can specify various props, like on the anchor found, for example, and you get the specific coordinates of the anchor in the real world. So you can attach anything to this real anchor. But in our use case, I wanted this quad to render, so it's a fairly common use case. So usually you have the sort of thing. So there is a helper for that. It's called plane selector. And that's basically do the whole heavy lifting. I just need to nest things inside, and it just works. So portals. Portals, the actual portal, yeah, it's possible true. If it was possible false, I will probably stay over there. It couldn't get out. No, just kidding. It just like gives you an ability to enter the portal. But there is a portal scene which is created by specifying a wrapper, specifying portal wrapper, the actual 3D model of the frame, and the 360 image. Now the cool part, you can do 360 video. So you can create a portal with a video inside, which can be kind of cool implementation for an app. Consider the following app. You have AR app with a bunch of, like a gallery for 360 videos, and you actually need to walk inside every video. So if you, like $1 million idea, right? So also we can do particles, which is pretty cool. You've seen these particles, these snow particles. This is done by particle emitter. It has various behaviors on it, like spawn behaviors and maximum particles and stuff like that. That's the whole science. There's the whole science behind the particle systems, particle emitters. So we won't have time to delve into the particles, but everything is explained in the doc, so check this out. And let's check out the second demo, which is this time on the phone, and I will hope it will work. Again, I prayed to demo gods. Nice. It worked. That's cool. So there is a new ARKit 2 version that came out, and it gives you several cool things. So right now, if you have a marker, and like previously before ARKit 2, if you had a marker, and if you point your app at a marker, you can render a model. That's a portal. You can render a model on the marker, but if you move the marker, it will just stay on the same place. So with the ARKit 2, you have continuous tracking. So I move the marker, and it just stays there, right? So yeah, you can do that to your business card. And sometimes it's a little bit laggy, but hey, nothing is perfect, right? So this is one thing. The second thing, and that's the reason why I brought the backpack, because I thought it would be weird to walk out with peanut butter jar on the stage. Yeah, it's not I'm hungry or something. But the thing is, with markers, we can scan images. But right now, we can scan actual 3D objects. So I have this object, and hopefully it will work. It's supposed to give some, yeah. So it's found an ARCore, and it gives like this 3D box, really bad looking. But the idea is I can scan this from any direction, and yeah, hopefully it will work. Yeah, because it worked already one time, but there is no continuous tracking on objects yet. But you can, for example, create an app. You walk through the store, you scan all these objects, and you point on the object, you get some kind of information or stuff like that. So there is an actually Apple application that lets you scan objects. So it's an object with AR object extension. You load this extension inside, similar as you load a marker in Vero Media. And then when this object is recognized by ARKit, you can load your stuff. So the question is, speaking of 3D stuff, where to get free 3D stuff? So there is a Unity asset store, which is pretty good. There are a bunch of links. All of these are links. So I will share a presentation later on Twitter, and you can click on these links. So the asset store gives you also free stuff, also like really cheap environments, FBX models and stuff like that. But the important part, because we are dealing with mobile and AR, we need to use real-time optimized models or low poly models, because we don't want to load model with huge amount of polygons and get really slow performance. There is a Turbo Squid, which is an amazing website with a bunch of paid stuff, but it has some free models. There is Sketchfab. Mick Simone is pretty amazing. Let me show you Mick Simone. It's over here. So Mick Simone is basically a service that gives you an ability to upload your character, and it has auto-rigging capabilities, so it can rig your character and expose it for animation. So let's change character to something more pleasantly looking. Let's use this character. So it loads the character. Yeah, and pretty slow because I'm on my phone tethering. So it'll take time to load, and then we have animations of the character. Oh, come on. What do you think? Should I use different character? No textures. Mick Simone, I tried to show how amazing you are. Why why do this thing? Anyway, I don't know what's with the textures here, but you can actually put some kind of animation. Let's just reload the thing. Yeah, so you can put some kind of animations here. So the cool thing, you can check characters. Yeah, so you can choose characters, but there is a limited amount of characters. And obviously, you want your own one, but there are a huge library of animations. So you can just take your character, upload their auto rig, use these animations. If you have Adobe account, it's for free. I haven't checked the license. Maybe you need to mention them or something. I probably should check the license. Yeah, yeah, because I have production stuff. Anyway, yeah. So you can model things in Blender, which means you need to be a 3D modeler. No, it means if you want, you can model just basic shapes, and then you can use premium textures to make these shapes look like more ready for production, I guess. And speaking about the textures, there is a Substance Painter and Substance Source tool, which is a paid thing, but what they have a library of textures, and they have a really cool tool for painting over 3D models. So yeah, links are really slow, so just check them later on. So the question is when to develop AR apps with Vero. Well, if, as I said before, if you have some kind of a game with lots of particle effects and stuff like that, probably you wouldn't use Vero for that. If you have like lots of stuff that you need to model, you need to see and stuff like that. But for most of AR implementations, like the actual apps, like retailer apps, manufacturing apps, stuff like that, you can freely use Vero for developing these apps. So when app is not a full-blown AR game, that's probably the answer. So start building AR apps today. You have these two demos here, and I will also tweet links to the slides and stuff like that. And thanks a lot for having me. Yeah, thanks.